we shall discuss about sets. What is set? Set means a group. So, set is a group of some defined things. It can be a group of boys in your class, a group of girls in your class, a group of children in your home, a group of couple at your home, a group of white pages in the book, a group of triangles in a group of squares. It can be a group of any other things, and it is represented with many letters. It can be represented by A, B to Z, and the representation of a set is like this. A is equal to, it is represented by, a set is represented by a letter, and it is equal to, and all the members of this set are put together in a flower bracket. So, if we say a group of even number from 0 to 10, then this set is represented as A is equal to, or a group of even number from 0 to 10 is equal to, into flower bracket, 2, 4, 6, 8 and 10. So, this is how we represent sets. So, this is the representation of a set defined as a set of even numbers from 0 to 10. So, this is how we represent. Always we represent the members of the set into a flower bracket, and it is denoted by any letter. So, this is how we represent sets. There can be various sets. There are universal sets, there are null sets. Universal set, by definition, it contains members where the members, universal set by definition contain many subsets. So, universal set is like a parent set. When we say alphabet, when we say a set of alphabet, then it can be a universal set for a subset of a set of vowels, because these vowels are a part of this alphabets A to Z. So, for this subset, a set of vowels, we can say that a set of alphabet from A to Z is a universal set. So, universal set is like a parent set for the subset. Let us see an example for a null set. A set of boys in a girls' college. A set of boys in a girls' college. Can there be any entity in this set? No, there cannot be any boys in a girls' college. So, this is a null set. Or take one more example. A set of trees on the moon. So, this becomes null set because there is no tree which can grow on moon. So, these two are the examples of null set, and this null set is represented by some A. Null set A is equal to pi. So, this is the representation of a null set, or it is also represented as A is equal to flower bracket without any entity inside. So, this is a null set. This is the representation of null set. So, universal set is a set. It is a parent set of many subset, and the null set is a set where there is no entity in the set. And we have seen the example, a set of boys in a girls' college. Can we find any boy students in a girls' college? No. So, it is a null set. And a set of plants growing on moon. Can there be any plants on moon? No. So, this is also a null set represented in this way. So, this is about what is set and what is universal set what is null set and the representation of them. Now, in arithmetics, you see various operations, not surgical operations, mathematical, that is arithmetic operations, that is addition, subtraction, multiplication and division. That is in arithmetic. Even here in sets, we have two kinds of operations. We have two kinds of operations called union of sets and intersection of sets.
ಮಕ್ಕಳು SSLCಗೆ ಬಂದರು, PUCಗೆ ಬಂದರು ಅಂದ ತಕ್ಷಣ ಪೇರೆಂಟ್ಸ್ಗೆ ತುಂಬ ಟೆನ್ಷನ್ ಶುರುವಾಗುತ್ತೆ. ಟೆನ್ಷನ್ ಯಾಕೆ ಮಾಡ್ಕೊಳ್ತೀರಾ? ಬೆಂಗಳೂರಿನ ದಶದೀವಿಗೆ ತಂಡದವರು SSLC ಓದುವಂತಹ ಮಕ್ಕಳಿಗೆ ಅವರು 9th ಪಾಸ್ ಆದ ಕೂಡಲೇ SSLC ಎಂಟರ್ ಆಗುವ ಮುಂಚಿನ ರಾಜ್ಯದಲ್ಲಿ 45 ದಿನಗಳ ಕ್ರ್ಯಾಶ್ ಕೋರ್ಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ದಿನಗಳ ಈ ಕ್ರ್ಯಾಶ್ ಕೋರ್ಸ್ನಲ್ಲಿ ಪೂರ್ತಿ ಸಿಲೆಬಸ್ಸನ್ನು ಅವರು ಕವರ್ ಮಾಡಿಕೊಡ್ತಾ ಇದ್ದಾರೆ. ಇದರ ಅಡ್ವಾಂಟೇಜ್ ಏನು ಗೊತ್ತಾ? ಇದರಲ್ಲಿ ಇರೋರು ಎಲ್ಲರೂ ನುರಿತ ಅಧ್ಯಾಪಕರು.
ಹೈಸ್ಕೂಲ್ ಹಂತದಲ್ಲಿರುವಾಗಲೇ ಮಕ್ಕಳನ್ನು ಆ ಪರೀಕ್ಷೆಗಳಿಗೆ ಸಿದ್ಧಗೊಳಿಸ್ತಕ್ಕಂತಹ ಪ್ರಯತ್ನ ಇದು. ನನಗೆ ತುಂಬ ಸಂತೋಷ ಆಗಿದೆ. ಯಾಕೆ ಅಂದರೆ ಕರ್ನಾಟಕದ ಹಳ್ಳಿಗಳಲ್ಲಿರ್ತಕ್ಕಂತಹ ಪ್ರೌಢಶಾಲೆಗಳ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಉತ್ತಮ ಶಿಕ್ಷಕರ ಒಂದು ಪಾಠ ಕೇಳ್ತಕ್ಕಂತಹ ಸೌಲಭ್ಯ ಇರುತ್ತೋ ಇಲ್ವೋ, ಅಂತಹ ವಿದ್ಯಾರ್ಥಿಗಳಿಗಂತೂ ವಿಶೇಷವಾಗಿ ಇದು ವರವಾಗಿ ಪರಿಣಮಿಸುತ್ತೆ. ಆದ್ದರಿಂದಲೇ ನಾನು ಹೈಸ್ಕೂಲ್ ಮಕ್ಕಳಿಗೂ ಕೂಡ ಚಿಪ್ಸ್ನವರು ಮಾಡಿರ್ತಕ್ಕಂಥ ಈ ಪ್ರಯತ್ನ ನಿಜವಾಗ್ಲೂ ಕೂಡ ಸ್ವಾಗತಾರ್ಹ ಅಂತ ನಾನು ನಂಬುತ್ತೇನೆ.
ದಶದೀವಿಗೆ ತಂಡದವರು ನಡೆಸುವಂಥ ಈ ಕ್ರ್ಯಾಶ್ ಕೋರ್ಸ್ಗೆ ನಿಮ್ಮ ಮಕ್ಕಳನ್ನು ಸೇರಿಸಿ SSLCಯಲ್ಲಿ ಎಕ್ಸೆಲ್ ಆಗೋದನ್ನು ನೀವು ನೋಡಿ.
So, as you have 4 operations in arithmetics, that is addition, subtraction, multiplication and division, in sets we have 2 operations, that is union of sets and intersection of sets. Let us see what is union of set and what is intersection of a set. Now, let us see what is the union of a set. It is an operation. So, union of set is nothing but it is a set where we combine the entity of the numerous sets. When we say A union B, that means that it gives a set which is a combination of both the sets. In the sense, the entity of both the sets are combined together. So, union of 2 sets is equal to a set which is having the entity which are combined. So, union of sets, that is union of set A and B, A union B is equal to a set which has entity from both the sets. Now, let us take an example. Let A be a set of numbers 1, 2, 3, 4 and 5. and B be a set of alphabets, that is vowels A, E, I, O, U. Now, A union B is an operation in set. So, A union B is equal to, when we use this operation union, we should combine all the entities of these two sets. So, this A union B becomes a set which has entities from both the sets 1, 2, 3, 4, 5 and A, E, I, O, U. So, this is how this operates, union operates. A union B is equal to a set which has entities from both the sets. So, union is an operation which combines all the entities of two sets together into a set. So, this is about union. Then, what is intersection? We say A intersection B. Then what it is? In union, we combine the entities of two sets together into a set. But in case of intersection, we are getting entities into a set only which are common to both the sets. Let A be a set of hapazoid numbers 1, 5, 6, 8, 9. Now, B be a set of even numbers from 0 to 8. So, 2, 4, 6 and 8. When we use this operation, that is intersection, A intersection B is equal to a set. So, when we use this intersection, we get a set which contain entity which are common to both of these sets. So, when we use this operation intersection, we get entity into the sets which are common to both the sets. See here we have 1, 5, 6, 8, 9 and in this set we have 2, 4, 6 and 8. So, when we say A intersection B, we get a set which have entity which are common to both. So, please note here 6 and 8 and 6 and 8 are common to both the sets. So, A intersection B becomes a set with entity 6 and 8 which are common to both the sets. So, this is how the union and the intersection operates. A union B is a set which has entity from both the sets. But in case of A intersection B, we have a set where the entity are common in both A and B. So, this is about two operations, union and intersection. We shall discuss a bit more about these operations. In arithmetic operations, that is with division, that is with addition, you know that it has got cumulative property. That means we can say that 2 plus 4 is equal to 4 plus 8, there is no change. 2 plus 4 is equal to 4 plus 8. This is the cumulative property of addition. Similarly, here in sets we have cumulative property of sets. Here sets also obey the cumulative property. That means that A union B is equal to B union A. In arithmetic, we have A plus B is equal to B plus A. There is no change in the value. It is equal. It is what we call cumulative property of addition. Even in sets with this union and intersection operations, we have cumulative property. This intersection and union also obey the property of cumulative property. So, here A union B is equal to B union A. So, in sets also union follows the cumulative property. Also, A intersection, A union, okay, also A intersection B is equal to B intersection A. Here again, this intersection operation also has got cumulative property. A intersection B is equal to B intersection A. When we intersect A and B, we get a set which is equal to a set when we intersect B and A. There is no change here. So, this is about the cumulative property of union and intersection. When we exchange these sets, there is no change as it is there for addition. This is about the cumulative property. Now, we should know that these sets, the operations in the set also follow what is called as associative property. In the set, they also follow the operation in the set. The operation in the set also follow this associative property. Then, what is this associative property? For example, in case of multiplication, we have A into B plus C is equal to A into B plus B plus A into C. This is what is called the associative property of multiplication. Dear students, now let us learn about three important properties of these operations, of this union and intersection operations of sets. In addition, subtraction, multiplication and division, you have seen that some of these operations follow cumulative property. They obey this cumulative property. That means that in case of addition, A plus B is equal to B plus A. There is no change when you interchange the digits in arithmetics. Similarly, here A union B will be equal to B union A. When you exchange these sets and use this operation of union, there won't be any change in the union. Now, let us see if it is true. Now, let us consider two sets, set A with entity A, E, I, O, U and set B with entity 1, 2, 3, 4, 5. Here, A union B is what? When we use union, then it means that we should combine all the entities. This gives us A, E, I, O, U, the entities of this, and 1, 2, 3, 4, 5. Now, B union A, it is a set which has entity from both B and A. So, it will give you a set of entity 1, 2, 3, 4, 5 and also A, E, I, O, U. Actually, it should be represented in flower bracket. Now, see here, A union B is A, E, I, O, U 1, 2, 3, 4, 5 and B union A is 1, 2, 3, 4, 5 and A, E, I, O, U. Observe here, this is a group of 5 numbers and 5 letters, and even here there is a group of same numbers and same alphabets. So we can say that A union B is equal to B union A. This means that union operation in the set, the operation union in the set obeys cumulative property. Now let us see if or whether the intersection operation of set will obey this property. For this, let us take an example. Let us have a set X with numbers 1, 2, 3, 4, 5 and set Y with numbers 2, 4, 6, 8 and 10. Now here X intersection Y. So it is what? X intersection. When we use this operation intersection, we should get the entity which are common to both X and Y. So 1, it is not there. 2, is it there? Yes. So write it here. And 3 is not there. 4, it is there. So 4. And 5 is not there. So this is X intersection Y. Now let us see Y intersection X. It is equal to Y intersection X. 2, is it there? Yes. Write it down 2. And 4, is it there? Yes. So write down 4. 6, is there? 8, is it there? 10, is it there? No. So 2 and 4 are the two entities of this set. See here, X intersection Y gives you a set, Y intersection X gives you a set, and both of them are same. So we can say that X intersection Y is equal to Y intersection X. So even the intersection operation follows the property of cumulative property. So both union and intersection have the cumulative property. Now you will understand it much better when we solve problems regarding this. So we have two important properties of union and intersection, that is cumulative property of union and cumulative property of intersection. That means that whenever you exchange the sets and use these operations, union or the intersection, then there is no change in that operation. So these intersection and the union follow the property, that is cumulative property. Now let us see one more important property, that is associative property.
ನಾನು ದಶದಿವಿಗೆ ಸಿಡಿ ನೋಡೋದ್ರಿಂದ ನನಗೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ತುಂಬಾ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ.
ಕ್ಲಾಸ್ ರೂಮ್ ಅಲ್ಲಿ ಹೇಗೆ ಪಾಠನ ಕೇಳ್ತೀವೋ ಅದೇ ರೀತಿಯ ಸಿಡಿನಲ್ಲೂ ಕೇಳಬಹುದು. ಅದನ್ನ 4 ಸಲ ಕೇಳಿದ್ರೆ 4 ಸಾರಿ ಸ್ಕೂಲಿಗೆ ಹೋಗಿದ್ವೇನೋ ಅಂತ ಅನ್ಸುತ್ತೆ.
ಈಸಿಯಾಗಿ ಪಾಠಗಳನ್ನೆಲ್ಲ ಒಂದು ಕಡೆಯಿಂದ ನೋಡ್ಕೊಂಡು ಬರ್ಬೋದು.
You can learn so many things just by watching that CD.
ಈ ಸಿಡಿ ನೋಡಿದ್ಮೇಲೆ ನನ್ನ ಮಗಳಿಗೆ SSLC ಭಯ ಹೋಗಿದೆ. ತುಂಬ ಚೆನ್ನಾಗಿ ಓದ್ತಾಳೆ, ಒಳ್ಳೆ ಮಾರ್ಕ್ಸ್ ಕೂಡ ತೆಗಿತಾಳೆ, ಆ ನಂಬಿಕೆ ನನಗಿದೆ.
Now let us see whether this union and intersection obeys the associative property. Now for this, let us take an example. First let us see whether union follows this associative property. Let us take this example where A is a set of A, B, C, D, B is a set of B, C, E, F and C is a set of C, E, F, G. Now, A union B union C is what? Now, first we should know what is A union B, and after finding out this set A union B, let us use operation between this set and this set. We get some set, and after getting that set, that should be equal to a set obtained from A union this set. This set is the set obtained by the union of B and C. Here we have applied this operation of union first between A and B, then we get a set, and we are operating this union again with this so formed set with the C. But in case of this, we are using this operation union between A and this set, the so formed set between B union C. Let us see, if both are equal, then we can say that this union follows associative property. Now let us see here, A union B is what? A union B, we have A here, B, C, D, and B already we have taken, C already taken, E is not there, and F. So A union B is what? A, B, C, D, E, F. This set we got A union B. First we applied this union here and we got this set. Now union C, C, E, F and G. Now when we apply this operation now, we get a set that is equal to A, B, C, D, E, F and C, E, F already there, so G. So we get this set. So this is a set that we have got by first applying this operation between A and B, then with the set which we have got after applying this operation, and now after applying, and now we apply this operation union between the so formed set and the C set, then we get this value. Now let us see what we get when we use this union operation between A and this set. So now in A set we have A, B, C and D. Union, this set union B union C. B union C is nothing but B, C, E, F, C, E, F is already there and G. So this is what is called B union C. Now let us see what is this A union, this is set A union, this B and C set. This is equal to again A, B, C, D, E, F, G. When we applied this union operation between A, B and got a set, and then applied this union between the so formed set and C, we got that answer. And again when we applied this operation union between A set and B union C set, we got that. So that means that A union B union C is equal to A union B union C. So hence this union obeys associative property. So this is how we can do that. The sets, in sets, union obeys the associative property. And also this union and intersection follows or obeys distributive property. That means that when we have three sets A, B, C, A intersection B union C is equal to, this is the union here. So, A intersection B union C is equal to A intersection B, A intersection B union A intersection C, A intersection C. It means that we can distribute this A with B and also A with C. There is no change. So, this union follows this distributive property, or rather it has distributive property. A intersection B union C can be written as A intersection B union A intersection C. How? A intersection B union A intersection C. This can be distributed with B, also with C. This is about distributive property of union. Similarly, even and also, this union and intersection follows or obeys distributive property. That means that when we have three sets A, B, C, A intersection B union C is equal to, this is the union here. So, A intersection B union C is equal to A intersection B, A intersection B union A intersection C, A intersection C. It means that we can distribute this A with B and also A with C. There is no change. So, this union follows this distributive property, or rather it has distributive property. A intersection B union C can be written as A intersection B union A intersection C. How? A intersection B union A intersection C. This can be distributed with B, also with C. This is about distributive property of union. Similarly, even A union B intersection C is equal to A union B, A union B intersection A union C, A union C. This means that even intersection has distributive property. They see here A is distributed to both B and A is distributed with C. So, it has got distributive property. You will understand it better when you solve some of the problems. Now, let us solve some of the problems associated with all this what we have learned. Now, let us learn an important law called Morgan's law. Before going into the details of Morgan's law, we should know what is a complement of a set. For this, let us take this example. Let us consider that this is an universal set of number 1 to 10. And here we have a set of even numbers 3, 5, 7, 9. So, this is a set of even number. So, here this is a universal set, this box represent an universal set with numbers 1 to 10, and in this we have a subset A. This is a subset A. Now, A is equal to 2, 4, 6, 8 and 10. When we say complement of A, that means it is a set with entity other than the entity present in the A set. So now A complement is equal to, see, in this universal set U, there are numbers from 1 to 10, but A complement means the entity of the universal set other than these entity. A complement means it is a set which contain entities, but these entities should not be in the A set. So now here 1, it is not there in A, so write it 1 here. 2, it is there in A, so we cannot write that. 3, it is not there in A, so write it. 4 is there, so don't. 5 is not there, so write. So, and similarly 7 and 9. So this is A complement. Now, with this basics in your mind, let us see what is Morgan's law. Dear students, you have learnt what is a complement of a set. With this basic in your mind, let us know what are the 2 laws of De Morgan. They are famously called as De Morgan's law. The first law of De Morgan, that is the first law of De Morgan, it states that A union B complement, the complement of a set formed by the union of set A and B is equal to A complement intersection B complement. De Morgan's first law states that the complement of a set formed by the union of 2 sets is equal to the intersection of the complement of both the sets. This law, let us try to understand by an example. Let us consider an universal set, that is with the entity 1, 2, 3, 4 and 5. I have represented it diagrammatically here. It is an universal set with entity 1, 2, 3, 4, 5. Now, let us consider a subset of this universal set, that is A, with entity 2 and 4. So, let us consider a subset out of this universal set with entity 2 and 4. Now, let us consider one more subset of this universal set with entities 3, 4 and 5. So, this is a subset of this universal set with entity 3, 4 and 5. So, in this diagram, this is a universal set. This box represents the universal set with entities 1, 2, 3, 4 and 5. And this circle, which is in blue color, indicates the subset A with entity 2 and 4. And this circle with pink color will indicate a subset B with entity 3, 4 and 5. Let us represent this as subset A and this as subset B. And also, as we already know, this is the universal set U. Now, look at this statement stated by De Morgan. According to De Morgan's law, A union B complement is equal to intersection of complement of A and B. Let us see if it is correct. Now, let us try to find out what is A union B complement. For this, first we have to find out A union B. A union B, when we use this operation union, as you know, we should combine all the entities of set A and set B. I repeat it again. When we use this operation of set union, we should combine all the entities of B and A in one set. So let us combine all the entities of A and B in one set now. So first let us write down the entities of set A. The entities of set A is 2 and 4. So 2 and 4. So because we have used this operation union, we have to combine even the entity of set B. The entity of set B are 3, 4 and 5. So write it here, 3, 4 and 5. Please concentrate here. This is A union B, but we want A union B complement, the complement of this set. Now, let us consider that this is a set where the entity are 2, 4, 3, 4 and 5. This we can rewrite as 2, 4, 3 and 5. I think you got this. As 4 is common, we can take it here. It is repeated, so we can take it here. So now this can be rewritten as 2, 4, 3 and 5. This is A union B. Now let us find out the complement of this A union B. By definition, complement is a set of a set. It is a set of a set where this complement set contains the entity of the universal set other than the set. In the sense, for example, this is a universal set. If we wanted to find out the complement of A, then we get a set. A complement is a set which contains entity other than the A set. Now, in universal set we have 1, 2, 3, 4 and 5. And we are trying to find out A complement for suppose. Let us suppose that we are trying to find out A complement. So, to find out A complement, we get a set which have entity of the universal set other than the A set. So, A complement will be having the entity in this set other than the entity which are present in the A set. So, it will have 1, 3, 5. So, this is the meaning of complement. But here we need the complement of A union B set. In the sense, we need to find a set which have entity of the universal set other than those present in this set. Now, complement of this set A union B is equal to, it is equal to a set. By definition, complement of a set will contain the entity of the universal set other than the entity present in the set. So now in the universal set we have 1, 2, 3, 4 and 5, and also in this set we have got 2, 3, 4, 5. As we have got 2, 3, 4 and 5, we cannot take these entities into this complement. We should take those entity of the universal set which are not present in this set. So 1, is it present over here? No. So it becomes an entity of this complement set. Now 2, it is present, so we cannot take that. 3, yes, it is present, we cannot take that. 4 is also present, and also 5 is also present. So A union B complement will give you a set, that is the subset of universal set with entity 1. So this is the value of A union B intersection, or intersection of A union B.
ಡಿ ತರಿಸ್ಕೊಂಡಿದ್ದೆ. ಪಾಠ ಎಲ್ಲ ಅರ್ಥ ಆಗ್ತಾಯಿದೆ, ನಾನು ಕ್ಲಾಸಲ್ಲಿ ಕುಂತಾಗೆ ಕಾಣಿಸ್ತಾ ಇದೆ ನನಗೆ. ಇದರಿಂದ ನಾನು ತುಂಬ ಇಂಪ್ರೂವ್ ಆಗಿದ್ದೀನಿ.
ಕ್ಯಾಸೆಟ್ ತರಿಸ್ಕೊಂಡಿದ್ದೀನಿ, ಅದರಲ್ಲಿ ಗಣಿತ ಮತ್ತು ವಿಜ್ಞಾನ ತುಂಬ ಸುಲಭವಾಗಿದೆ. ಮತ್ತು
ಈ ಸಿಡಿಯಿಂದ ತುಂಬ ಚೆನ್ನಾಗಿ ಎಲ್ಲ ಸಬ್ಜೆಕ್ಟ್ ಅರ್ಥ ಆಗ್ತಿದೆ.
ಈ ವರ್ಷ ಬೇರೆ ಸಿಲೆಬಸ್ ಎಲ್ಲ ಚೇಂಜ್ ಆಗಿದೆ, ಪ್ಯಾಟ್ರನ್ ಎಲ್ಲ ಚೇಂಜ್ ಆಗ್ತಿದೆ, ಹೇಗೆ ಬರೆಯೋದು ಅಂತ ತುಂಬಾ ಭಯ ಇತ್ತು ನಮಗೆ.
ನಾನು ದಶದಿವಿಗೆ ಪ್ರೋಗ್ರಾಮ್ ಕ್ಯಾಸೆಟ್ನ ತೊಗೊಂಡಿದ್ದೀನಿ. ಈ ಕ್ಯಾಸೆಟಲ್ಲಿ ತುಂಬ ಚೆನ್ನಾಗಿ ಲೆಸನ್ಸ್ನ ಮಾಡಿದ್ದಾರೆ. ಈ ಲೆಸನ್ಸ್ನ ನೋಡಿ ನನಗೆ ತುಂಬ ಉಪಯೋಗ ಆಗಿದೆ.
ಆದರೆ ಈಗಂತೂ ತುಂಬಾ ಈಸಿ ಆಗ್ತಾ ಇದೆ ಬರೆಯೋದು, ಮತ್ತು ಹೇಗೆ ಬರೀಬೇಕು ಅನ್ನೋದನ್ನೆಲ್ಲ ಚೆನ್ನಾಗಿ ಹೇಳ್ಕೊಡ್ತಾ ಇದ್ದಾರೆ.
ಈ ಸಿ ಡಿ ನೋಡಿದ್ಮೇಲೆ ನನ್ನ ಮಗಳಿಗೆ SSLC ಭಯ ಹೋಗಿದೆ. ತುಂಬ ಚೆನ್ನಾಗಿ ಓದ್ತಾಳೆ, ಒಳ್ಳೆ ಮಾರ್ಕ್ಸ್ ಕೂಡ ತೆಗಿತಾಳೆ, ಆ ನಂಬಿಕೆ ನನಗಿದೆ.
Let us see what is A complement. A complement, as you know, complement of a set will contain those entity of the universal set other than the entity present in the set. Now, 1, is it present in A? No, so we can take it. 2, is it present there in the A set? Yes, so we cannot take 2. 3, is it present there? No, so we can take 3 here. And 4, it is present in the A, so we cannot take, and 5 is not present, so we can take this. So A complement is equal to, it is a set of 1, 3, 5. So mark it as equation 2. Now let us find out B complement. Again, B complement is a set which should contain the entity of the universal set which are not present in the B set. So now universal set 1, is it present there in the B? No, so we can take 1. 2, it is not present in the B, so we can take 2. 3, 4, 5 are present in the B set, so we cannot take 3, 4, 5. So this is B complement. So now here we need to prove that this A union B complement should be equal to A complement intersection B complement. Let us see what is A complement intersection B complement. A complement intersection B complement is equal to, when we use this operation intersection, we get a set which have entity which are common to both of these sets. Please look at this. A complement has entities 1, 3 and 5, and B complement has entities 1 and 2. When we apply the operation intersection between these two sets, we get a set which has entity which are common to both the sets. So see here, 1, it is there in both the sets. So 1 can be in the set of A complement intersection B complement. 3, is it there here? No, it is not common to both the sets. So it cannot come into the set of A complement intersection B complement. 5 is also not a common one. So in a set of A complement intersection B complement, we get only one entity, that is 1. So mark this as equation 3. Referring back to equation 1, where we have found out the value of A union B complement, rather complement of A union B, which is equal to 1, where the complement of A union B is equal to 1, and refer to equation 3, where A complement intersection B complement is also equal to 1. That means that both are equal. Now let us go to the next question. verify the cumulative property of intersection of sets for given sets of sets. Now here set A is L, M, N, O, P, Q and set B has entities M, N, O, R, S, T. Now we are asked to verify the cumulative property of intersection. So cumulative property of intersection says that A intersection B is equal to B intersection A. So this we have to verify. So for this, let us find out A intersection B and B intersection A, and then let us compare them. First, let us find out A intersection B. A intersection B is a set which contain entities which are common to both A and B. So see here, we have L, M, N, O, P, Q and there M, N, O, R, S, T. Among these, M, N, O are common to both. Is it not? Yes. So A intersection B is M, N, O. Now let us find out B intersection A. Now here again see B intersection A. M, it is present, so we can write M. N, it is present here, so we can write N. O, it is present even here, so we can write O. R, is it present here? No, so we cannot write. R, yes, is it present? No. T, is it present here? No, so we cannot write the other three. So B intersection A is M, N, O. See here, compare these two equations. Here, these hand sides are equal. That means that A intersection B should be equal to B intersection A. So, hence it is verified. So, dear students, for given sets of sets, we have verified that the cumulative property of intersection holds good.